Thanks for joining me. This lecture topic is entitled Improving Script Execution Overview. In my early years of performance testing on the mainframe, it used to be somewhat simple with application response time. The user expectation of IMS and CICS application screen rendering could be 1 to 5 seconds on average. Now, with the multi-tiered client-server environments, you have client machines dialoguing with servers and servers interacting with other servers. The latency between each data point can be significant because of all the chatter to confirm the data was received as expected. Security requirements are now in high demand, adding overhead to information passing between server points. All this is now resulting in client-side rendering or response time averages not always meeting the 1 to 5 second range. In the client-server world, there is security threats and security authentication and authorization to manage the threats between every server. This web authorization protocol conversation is necessary but might impact response time if security measures in use are more than necessary. This concept can impact logging, buffering, queuing technologies. Thus, the need for a tool like JMeter having functions and features that capture dialog events efficiently. When JMeter tests are executed, we can enhance the test results with the use of listeners that collect various kinds of performance data and organizes it into useful analytical reports. The scripts developed in JMeter are designed to create the traffic needed to dialogue with the target application, but also collect performance data for reporting and analyzing in a controlled manner. Let's talk a little bit more about JMeter GUI and command line test executions. I mentioned earlier that if you have a large amount of computer memory and CPU power, you can get away with running many performance tests in JMeter GUI mode. If that is not the case, another approach is necessary. I once had a team of 2 additional test analysts, so for many of our performance test sessions, I divided 30 JMeter scripts split into 3 physical JMeter JMX files. We connected vocally and each started one of the 3 JMeter scripts from our machine. And these are compound scripts that had several individual scripts within them. And this created the real traffic needed on the target SaaS application, SaaS. When the test completed, we collected all the test results in one place for analysis. Some of the listeners produce report output that can be written to files, which can then be collected and loaded into Excel sheets for creating graphs. This approach worked and kept the team involved in the test execution and analysis. Here's a diagram that depicts the process. A team can execute JMeter at the same time to generate a different set of traffic or run a different group of application functions to emulate many users interacting with the application under test. The results can be collected into Excel's charts and graphs for analysis and reporting. In summary, whenever a script is intended to run for an intended time or is intended to reach high performance load levels, it is important to run in the command line mode. If your laptop or desktop has a large amount of memory, 16 gig or higher, and high CPU capacity, then it is possible to still run tests in the GUI mode for more than 1,000 concurrent users. As the number rises, you need another method. Now, there is also the distributed mode option. This is where you set up more than one machine to conduct JMeter performance testing. It is a master-slave concept, which is intended to operate in an unattended mode. Your machine can act as the master, while one or more other machines can act as slaves. The master machine initiates the dialog and invokes the slave machines by IP address. The approach enables distribution of multiple machines to interact together and conduct a performance scenario test utilizing the resources of multiple machines. This approach involves treating other accessible machines as slaves to a master JMeter machine. It still requires each slave to have its own JMeter script, but all slaves are controlled by the master, and outputs then must be collected centrally. A key thought to remember is if you are not able to supply JMeter with sufficient memory and CPU power, then the command line method for JMeter execution should be utilized. To run JMeter in command line mode, which means without any user interface, run the following command. As you see here, JMeter -n-t scenario.jmx file -l jmeter.jtl, what file you want the output to go to. The command line has the following parameters. The -n run in a non-GUI mode, and the -t tells it to specify the path where the script is, and the -l specifies the path to the JTL file, which will contain the raw output results. One more time, the syntax for the JMeter execution in non-GUI mode is JMeter followed by -n followed by -t with the location of the JMeter script, and then -l and define the location of the result file. You can also specify -e, then -o for the location of the output folder. My time has ended for this session. I thank you for yours. Join me in the next video.